Until now, momentum and impulse have been fairly useful in helping us to understand the effect of forces on an object. However, if you have been listening with a skeptical ear, you might be saying to yourself that all of the problems that we have worked on could have been done using the fact that force is equal to mass times acceleration, and that the acceleration times time is equal to the change in the velocity. So it may be easier to do these problems this way, where we use the momentum and the impulse, but we haven't really learned any truly new physics. Well, the real power of the concept of momentum is that the linear momentum of a system is conserved if there's no external force on the system. One way of thinking about this is that according to Newton's third law, for every force acting on an object, the reaction force is equal in magnitude and in the opposite direction. So, the force AB is equal in magnitude and in the opposite direction as force BA. The force is equal to the change in momentum divided by time. The change in momentum of object A is equal to the force on A by B times delta t, and the change in momentum of object B is the force on B by A times delta t. The force on B by A is equal to minus 1 times the force on A by B. The time over which the forces act on each other will also be exactly the same, so the change in the momentum of A and B added together will be equal to force on A by B times delta t minus the force on A by B times delta t, which is exactly 0. Notice that this is a totally general form here, so for any complicated force over any period of time, as long as the only forces are the force acting between A and B, then the change in the momentum must be 0. Another way of thinking about this is that the initial momentum of the system must be equal to the final momentum, as long as there is no external force. The law of conservation of momentum is universal. It holds at relativistic speeds and also in quantum mechanics. So, the key point here is that the initial momentum and the final momentum of an isolated system must be exactly equal to each other. You can lose energy to heat, so there's no such thing as conservation of kinetic energy, but no matter what, the initial momentum and the final momentum must be equal to each other. On the next page here, you have a question about what happens if a ball collides with a stationary ball. The question is it possible for both balls to be stationary immediately after the collision? Well, the initial momentum has some value since one of the balls is moving, so is it possible for that final momentum to be exactly equal to 0? Or does that violate the conservation of momentum? Alright, I really just wanted to introduce the concept of conservation of momentum today for the so-called Wednesday class. We're going to spend pretty much the entire class going over different applications of the conservation of momentum. Alright, good luck with the last question here, and take care of yourselves.